Olfaction.
Mm-hmm.
Walk me through it. You guys should know this.
You got it. Who wants to go?
Yeah, your odorants that enters the nasal cavity.
So you just said there's a mucous membrane, right?
Mm-hmm.
You have these little particles come, they dissolve in it, and they're called odorants. They bind to what?
Well, I think it's a specific receptors.
Specific receptors on cilia,
Yeah,
right?
cilia. Mm-hmm.
Or the olfactory hairs.
Those are the little ones, yeah.
Okay?
Okay.
So now let's go into how that works. Okay? So we're inside the nose. We've got our lipid bilayer, right? What kind of receptor is it? They're general categories. Like, is it a voltage-gated receptor?
Mm-hmm. I don't think so.
What is it?
We're talking at the neuron level, obviously. Alright.
Below the neuron level, I guess.
We're talking about cause of action potential, I assume.
Yeah.
Receptor.
It's a ligand gated. Nope, I don't know, honestly.
G protein,
Okay, G protein.
Right, because you have the alpha, beta, and
gamma subunits, right?
And then you have your something cyclase, adenylate cyclase.
Adenylene cyclase.
So this is actually talking about when the odorant attaches to the protein, and then what happens to cause the action potential.
Correct.
Okay, bueno.
So you've got alpha, beta, and gamma subunits. Do you guys remember G proteins?
Yeah. The alpha is one that detaches, right? And then it connects to.
So the odorant binds,
Mm-hmm.
it activates this G protein. The alpha subunit breaks off and goes and energizes what?
Adenylate cyclase.
Yep, adenylene cyclase.
Which ones of the wonderful special senses don't use G proteins?
Sodium and hydrogen and
Taste.
gustation.
Hearing doesn't, right? Because it has the little springs that open sodium channels.
Yeah,
Or was it chloride? Oh, that's a test question.
potassium.
It was potassium?
Uh-huh.
Oh, stinky.
But yeah, those are those hearing and those two specific taste cells
Everything else
in
has them.
gustation.
Cool.
Yeah.
Okay.
Okay.
Thank
I had to
you.
think through.
Yeah, that's a lot to think through.
Yeah. Okay. Adenylene cyclase. When adenylene cyclase is active, what does that do?
It opens your.
One other thing, it increases the activity of cyclic.
Oh yeah, something hits it and bounces off. Something else. But I can't remember.
Anyone?
Just
Like, this is the first time
Yeah.
I've ever even heard of this.
Cyclic AMP. You knew it. Just sitting there all silent back, letting them suffer. How dare you?
I'm alright with it.
It's fun that way.
Increases cyclic AMP.
So alpha leaves, goes attached to adenylene cyclase, which then increases the activity of CAMP.
Cyclic AMP.
Cyclic AMP.
Mm-hmm. Cyclic AMP then does what?
activates your
Channels?
sodium channel.
Uh-huh.
Okay.
So you've got these sodium gated channels.
It opens up,
Opens up, sodium
comes in,
flows in, causes a
action potential.
depolarization event. I'm trying to think if it's an action potential right here. Give me a second. I think it does cause an action potential here. Cited doesn't until the very, like, it depolarizes, but it's not an action potential.
Just graded potential.
It's, yeah, they're local potentials until the ganglion cells.
Okay, yeah.
Now there's the photoreceptors, the bipolar, and then the ganglion.
Mm-hmm.
It's not an action potential till down
it's the
here.
ganglion, yeah.
Yeah,
Hmm.
whereas before it's local potential. That's why I was trying to double check if it was an action potential. But yeah,
Okay.
depolarization event causes an action potential. Okay? Goes up, synapses, right?
Yes.
Which are just some secondary neurons in the olfactory bulb. Then where's the pathway? The neurons.
Hey, this is a bad module for me.
Well, it goes several different places, doesn't it? It goes to your.
Oh wait, are we talking about like where it goes?
Yeah.
Oh, it goes to the temporal lobe. Temporal lobe.
It goes to the temporal lobe, and it also goes to the frontal lobe in the end.
Does it? That's cool.
Mhm. So places that it goes, you've got, so what, real quick, what cranial nerve is it traveling down?
Oh, we got
The
this.
olfactory nerve.
Olfactory, which is number?
It's one of the first three.
Factory.
One.
Oh yeah, it's number
It's
one.
one.
Yeah.
It's the first one.
It's number one.
Factory bulb.
Okay. And then, where does it go? So it goes to, there's the primary
Okay. Which is-
olfactory, give me 1 second. So it's the primary olfactory area, which is in the temporal lobe.
Okay.
Okay. So it's gonna go
Up it goes.
cranial nerve number 1 to primary olfactory area. And then it can go to one of two places.
For storage, I think.
First.
Yeah, your brain stores places certain.
Yeah, but I don't want to store smells, I'm sorry.
Well, you do.
No, not really.
Not for storage, no.
No.
It's the medial olfactory area or the intermediate olfactory area, okay?
You don't believe me.
I'm just saying,
Somebody
I
needs
don't
to
want to
go
store
study.
smells, that's all.
You don't want to, that doesn't mean you don't.
Got that right.
I'm just saying.
You tell me what you think of when you smell bread. You don't recognize it. Something's wrong. Medial olfactory.
What's bread?
Well, good luck.
Okay.
We're being so negative today. What is this?
The medial olfactory area, which is in the frontal lobe,
Cool.
okay, is in charge of an emotional and visceral response.
Amygdala. Oh no, no. Venula. There we go.
That's in the episode.
All I know. is
And
not-
then the intermediate olfactory area is in charge of sending signals back to
in
inhibit,
the anterior part.
modify, inhibit. Okay?
That's like after a few minutes, you just don't smell it as much, right? That's because the intermediate olfactory area is intermediate.
It's sending inhibitory signals back.
Mm-hmm.
Okay.
Wait, did you say where the intermediate olfactory area was?
The medial and intermediate are both in the
Oh,
frontal
they're
lobe.
both, okay.
So what's the oh, the primary olfactory is in the temporal. Is that right?
Mhm.
Beautiful.
And thus you have olfaction. Okay, what? You said you had olfaction questions. Was there anything else besides this that you had a question about in olfaction?
No.
Okay.
It's a beautiful, simplified thing. I love it. All on one board. I love that.
Okay, but keep in mind we didn't label everything, for example, like,
The basal cells.
yeah, the basal cells and supporting cells, and this cribriform plate, things like that. Okay,
Okay.
so that was just the process, just physiology, it didn't
Yeah.
give a lot of
That's the
extra
good part of
details.
it.
Okay,